Welcome to the notes on polygons. So what is a polygon? Well, a polygon is a shape with three or more sides, must have three or more sides. That's the first thing you need to know about a polygon. And then there are several important characteristics. Okay, so not only does it have three or more sides, it cannot have any curves, no curves, okay, no curves. All right, and it has to be a closed figure. And then the third thing we'll talk about is only two segments. So only two segments can meet at a vertex. And we'll remind you guys what a vertex here is in a second. So here are some of the problems you'll see. You just have to basically determine whether or not the following shapes are polygons based off those characteristics. We look at the first one. There's no curves. It's a closed figure, three or more sides. So that's a yes. This one, again, it's enclosed. There's no curves. Only two segments meet at each vertex. So again, that's yes. This one right here, however, is no, all right, because of those curves. All right, so no curves, so that is a no. And then the next one is also no, but let's take a look at why. Remember, the vertex, it's where all of the sides or two sides meet. So all of those are vertex. Okay, we're really going to focus on that vertex in red. Let's take a look at how many segments meet at that vertex. Here's one segment that meets there. There's two segments that meet at the vertex. But if you look, there's a third segment that also meets there. So this does not meet that third criteria. So that is a no. And then finally, this one is also a no because it's not a closed figure, all right? It's open right here. So that is a no. Convex versus concave. They're going to ask you, hey, is this a convex or a concave polygon? All I need to know is convex has no indents and concave has indents. And this right here, that's an example of an indent. Okay, so cave in, indents. All right, convex, no indents. All right, terminology. We've used these before, but it's worth repeating. Equilateral, all the sides are the same. Equiangular, again, there's the word angle, all angles the same. Lateral refers to sides. And then regular polygon, super important. A lot of people miss that. If it's regular, it's angles and sides that are congruent. So be aware of that. We get into some naming of polygons. There's a chart with the number of sides and what we call each one. Again, anything over 12 or anything that's not listed here, however many sides, that's what we call it. If it's 11-sided, we call it an 11-gon. So now here is the diagonal that connects the vertex. Again, a vertex or the angle, all right? Again, it connects the non-consecutive one. Obviously, it doesn't connect the one that's right next to it, but it connects any other angle. We can draw a bunch of these on here. These are all examples of diagonals. There's one to there, okay? And there's, so all of these are examples of diagonals. You guys know that. Now, here's the one piece of information that you need to know, all right, that's new. The sum of the angles in a quadrilateral. We know the sum of the angles in a triangle. Well, a quadrilateral has one more side, so we're going to add 180. So the angles in a quadrilateral add up to 360 degrees. That's going to be a key idea. We've done these problems with triangles. Here's how one works with a quadrilateral. Find angle Q and R. Well, here's all the angles. We're just going to add them up. So I've got X plus 80 plus 70 plus 2X, and that's going to equal 360. From here, we just combine our like terms. I've got an X here and a 2X there. So I'm going to have 3X, and then I've got an 80 and a 70. So that's going to be plus 150 equals 360. Now you guys are pretty good at solving equations. Subtract 150 from each side. So 3x equals 210. And then we're going to divide by 3. So x equals 70. Now I'm not done. It says find angle Q and angle R. So I need to plug that in. So angle Q then is going to equal just 70 degrees. There's one of my answers because it's just X. And then R, angle R right here, well, that's going to be 2 times 70. So that one is going to be 140. So there's my other example. And there you have it. There's our lesson on polygons.